Okay, these are the notes for 7.3 about reference angles and degrees and radians on page 9. Your learning targets today are to convert between degrees and radians and to find the reference angle in degrees or radians. So in standard position, it's an angle with a vertex at the origin measured to the x-axis. So in this picture, if this is the x-axis and this is the y-axis, and then this is a circle around it, the standard position would be starting here. This would be considered 0 degrees on the x-axis, and you would rotate around in this direction. This is standard position, where this is some angle in degrees. Positive angles are angles that are rotated from standard position counterclockwise. So notice this is against where the clock turns, so this is counterclockwise. If we turn this much, notice that is a full 90-degree angle. This would be another 90 degrees, so that would be 180. Another 90 degrees would be 270. And then all the way around the full circle would be 360 degrees. Negative angles are the angles rotated from standard position clockwise. So this is going the opposite direction. So it's still starting here as your 0 point, but now we're rotating in the negative direction a certain degree. So notice if you rotate down to the bottom here, this would be 90 degrees. And then another 90 degrees would make 180. Another 90 would make 270. And all the way around the full circle is 360. So notice the 90 and 270 switch depending on which order you turn. So we're going to draw an angle in standard position. So we need to draw our x and y axis. At 60 degrees, I know it's less than 90 degrees, so we're starting here at 0, and it should be less than 90 degrees, so it should look something like that. For part B, draw an x and y axis. We're going 225 degrees, so that means we're starting here at 0. We've got 90, 180, 270. Notice 225 is between 180 and 270, so we're going to draw in our angle through here. So notice that's more than 180, less than 270. Part C, going in the negative 100 direction. So now this is still our starting point. We're rotating now clockwise. So this is 90. Notice 100 is a little bit more than 90, but less than 180, so it should be between here. And that's about 100 degrees in between. Part D, 390 degrees. We're going back counterclockwise, so starting at 0. We have 90, 180, 270, 360. Notice I have to keep going by another 30 degrees. 30 degrees is less than 90, so it's only going to be a little bit more. So our angle should be drawn in right there. Reference angles. These are the degree that's formed at the origin when a vertical line is drawn to the x-axis. So we have the first few drawn for us. We have our angle drawn in. So what you do is you draw a line from this angle up to the x-axis, and that should create a right angle. Your right angle will always be with the x-axis. And our goal is to figure out what our angle inside this triangle is. That's called the reference angle. So notice if this is 300 degrees, this inside the triangle has to be 60 degrees to complete the full circle. So if this part was 300 degrees from here to here, the part inside the triangle has to be another 60 degrees to go around a full circle of 360. So our reference angle is 60 degrees. You always have to have your answer inside the picture and outside the picture. There's a reason for that. It'll have to do with tomorrow's lesson. Okay, this time we are told that this part is 145 degrees. We're going to draw a line from here to the x-axis to create a right angle. So if that's 145, notice that's just less than 180 by 35 degrees. That's the angle in our triangle, so that is our reference angle. Okay, this one we're going from the line, we're going to draw it up to the x-axis, creating a right angle. Notice this was 225 degrees. Notice that's more than 180 and less than 270. I'm trying to figure out how much more than 180 is in my triangle. In this case, it's 45 more degrees. So my reference angle is 45. For number 3, I have to make a sketch for all of these and find the reference angle. That means I have to draw an X and Y grid. I have to draw a 150 degree angle, so that's going to be starting off at 0. We're going counterclockwise, so that's 90 and 180. Notice 150 is in between there, so we're going to draw a line somewhere in between. From that line, you draw it down to the x-axis, creating a right angle. This part is 150 degrees. I'm looking for how many degrees are in my triangle. So that would be another 30 degrees. So my reference angle is 30 degrees. You don't need any of these outside numbers. They just kind of help guide you. You do need the number in the triangle, and you do need to have it written outside. So 60 degrees, draw another T. If this is 90 degrees, we know we're not going to go that far. So it's going to be somewhere here in quadrant 1. Draw a line down to the x-axis, creating a right angle. So we're looking for this angle in here. Notice that would be 60 degrees. So my reference angle is 60 degrees. Make sure you have it in the triangle and outside. Part C, draw a T. We're still going counterclockwise, so we have 90, 180, 270. Notice it's between 90 and 180, so draw a line. Connect it to the x-axis, creating a right angle. Notice this angle is 135 degrees. We're looking for how much has to be left in the triangle to complete this 180. So this would be 45 degrees. So my reference angle is 45. Make sure you have at least the 45 in the picture and you have the 45 outside the picture. Part D, another T. Starting off at 0, we're going counterclockwise, so we have 90, 180, 270. Notice 210 is more than 180, but it's less than 270, so it's going to be down here in quadrant 3. We have to draw a line to the x-axis to create a right angle. We're looking for this angle here. So notice if this angle was 210, that's more than 180 by how much? 30 degrees. So my reference angle is 30 degrees. I don't know why that went away. Okay, part E, drawing a T for our X and Y axis. We're going in the negative direction 30 degrees, so we're starting off at 0, but this time we're going to rotate clockwise. So notice we're not going to go 90 degrees, we're going to go less than that, so somewhere here. Draw a line up to the x-axis, creating a right angle. We're looking for how much is in my triangle here. Notice I only rotated in 30 degrees, so that should be the angle in my triangle. So my reference angle is 30 degrees. For F, draw a T. We're going negative direction again. So starting off at 0, we have 90, 180, 270, 360. Negative 300, that would be between 270 and 360, so it's going to be somewhere around there. From that line, draw a line down to the x-axis, creating a right angle. So if this part was 300 degrees, we're looking for how much is left in the triangle. So to notice if it's a full circle, this would be 60 degrees. Make sure you're never finding the angle over here outside the triangle. We're always looking for the angle inside the triangle. So this is a 60-degree reference angle. Part G, draw an x and y axis. We're going in the negative direction, so starting at 0, this would be 90, 180, 270, 360. Notice I have to keep going, so it's more than 360 by a little bit. Draw a line to the x-axis, creating a right angle. So how much more than 360 was that? Well, it was 30 degrees more than 360, so my reference angle is 30 degrees. Last one, part K, we're going negative 495 degrees. In the negative direction, that would be 90, 180, 270, 360. Notice I have to keep going. So if I add another 90 to 360, that's going to put me at 450. Notice that's still not enough. If you go another 90, that would put you at 540. Notice that's too far. So it's between 450 and 540. We're going to draw the line and connect it up to the x-axis. So we went a full 360, and then we went another 90, and then another 45, leaving us with another 45 inside my triangle. Notice how all of the problems today are special triangle angles. So they're either 30, 45, or 60 degrees. A little hint is if the degree ends in a 5, the reference angle is probably 45. If it ends in a 0, then it's either 30 or 60. Okay, now we're going to do all of this again, but this time it's going to be with a radian measure. A radian is the length of one radius on the circle. So if this is a radius, the radian is the length of that radius on the circle. So if it's a full circle, if you think about 2 pi r is the circumference of a circle, if the radius of this is 1, it'd be 2 pi times 1, so a full 360 degrees is 2 pi. If I only go half the circle, it'd be 1 pi. So notice if this is 1 pi, this is only half of a pi. So notice if this was 0, we have half a pi, 1. This would be 1.5 pi, so that'd be 3 pi over 2. And then 2 pi. So every 90 degrees is half of a pi. So half a pi, 1 pi, 1.5 pi, 2 pi. Notice how 2 pi is equivalent to 360, and 1 pi is equivalent to 180. We're going to use that to convert a radian into degrees. So if you are given a radian, you would multiply that by 180 degrees over pi. The reason is because 180 degrees and pi are equivalent, so it's like multiplying by the number 1. If you want to convert a degree to radians, you multiply the degree by pi over 180 degrees. So you just flip this. So we're supposed to convert each angle from degrees to radians. So starting from degrees, we're going to multiply this by pi over 180. Notice you know the degree has to be on bottom, so the degrees cancel. So when I multiply across, we have 30 times pi over 180. We have to reduce the fraction, so 30 over 180, 30 goes into 186 times, so it's pi over 6. Let's do that again. We're taking this and converting it to radians. So we multiply by pi over 180. Notice the degrees cancel. So I have negative 245 times pi on top over 180. You can type in negative 245 divided by 180 into your calculator and go math fraction. It will reduce it for you. Don't plug in the pi, just leave the pi out of it. But if you do negative 245 divided by 180, math fraction, it reduces it for you to get negative 49 over 36. And then you just have to remember to leave the pi on top. 225, we're going to multiply by pi over 180. So multiplying across, 225 pi over 180, where the degree units cancel. Typing into my calculator 225 divided by 180, math fraction, you get 5 pi over 4. So it's 5 over 4, but remember the pi is on top. Now we're going to go the other way. This is in radians, and we're going to convert it to degrees. So notice you don't want the pi on top, you want to cancel the pi, so now the pi is on the bottom. That way the pi's cancel. So now I have negative 4 times 180 degrees pi over 3 pi. Notice how the pi's are going to cancel. So now I just have to figure out what negative 720 divided by 3 is, which is negative 240 degrees. Part B, multiplying by 180 degrees over pi. We're doing 5 times 180, which is 900 pi, over 12 pi. Pi's cancel. 900 divided by 12 is 75 degrees. Part C, multiplying by 180 degrees over pi. Pi times 180 is 180 pi. 4 times pi is 4 pi. The pi's cancel. 180 divided by 4 is 45 degrees. For number 3, we're going to evaluate the following trigonometric functions with a calculator. Round answers to 4 decimal places. Remember to change the mode of your calculator. So notice some of these are in radians and some of these are in degrees. I'm going to start by doing all of the ones in degrees. So notice B is in degrees because it has a degree symbol. D is in degrees, not E or F, but G is, and H is. I'm going to put a little D to remind me to be in degree mode. Notice all the other ones have a pi, so that's telling you it's radian mode. So for the first one here in part B, we're going to just type in cosine 135 degrees, make sure you're in degree mode, and you should get negative 0.7071. Skipping to D, we're typing in sine 55 in degree mode. You should get 0.8192. Jumping down to G, there's no secant button, but we can type it in as 1 over the cosine of 315 degrees and get 1.4142. There's no cotangent button, so we're doing 1 over the tangent of 76, which is 0.2493. Okay, so let's go ahead back up to A. We are going to change the mode on our calculator to radians, and then we are going to type in the tangent, find the pi button, divided by 7. You don't want to substitute 3.14. It has to be the pi button. So tangent of pi over 7, you should get 0.4816. For part C, it's also in radians. We have cosecant. That's going to be the reciprocal of sine. Remember, it's opposite of what it should be. So it's 1 divided by the sine of pi over 9. When you type that in, you should get 2.9238. Going to E, secant is the reciprocal of cosine. So this is 1 over cosine negative 2 pi over 3. That should give you negative 2. And then finally in part F, we're doing sine of 4 pi divided by 5. You should get 0.5878. Okay, last page is to make sketches of these radian measures. So we are drawing our t or x and y axis. This time we have to mark where 3/4 of a pi is and then find the reference angle. So remember, every 90 degrees is half of a pi, and you always start here at 0. So we have half a pi and 1 pi. So notice 3/4 of a pi is more than half of a pi, but less than a full pi. So we're going to draw our line here, connected to the x-axis, making a right angle. If this is 3/4 of a pi, what's remaining as our reference angle is 1/4 of a pi, because that would fill up the rest of the full pi here. So my reference angle is pi over 4. Again, you only need the measure inside the angle and then written outside. You don't need any of these other parts. They're just there to help you. Part B, draw an x and y axis. We're going pi over 6. That's going to be counterclockwise. Notice that's less than half of a pi. So that's going to be over here in quadrant 1. Draw a line to the x-axis, creating a right angle. And this was rotated pi over 6. So that is my reference angle. Make sure you have it in the picture and out of the picture. Part C. We have 5 pi over 4. Notice this is an improper fraction. We want to convert that to a mixed number. So 4 goes into 5 one time with 1 left over. So it's going to be 1 1/4 pi. That will help you in drawing your sketch. So if you're going 1 1/4 pi, every 90 degrees is half a pi. So there's your half a pi 1, 1 1/2, 2. Notice 1 1/4 is more than 1 pi, but less than 1 1/2 pi. So it's between 1 and 1 1/2 pi. Connected up to the x-axis, creating a right angle. Since it's more than 1 pi by 1/4 pi, that is my reference angle, pi over 4. It should be inside the picture and written outside. Part D. Notice we have another improper fraction. We should write it as a mixed number. So 3 goes into 4 once with 1/3 left over. So it's 1 1/3 pi. Draw your picture. So we have half a pi 1, 1 1/2, 2. Notice 1 1/3 pi is more than 1 pi, but it's not quite 1 1/2 pi. So it's in between again. Draw a line up to the x-axis, creating a right angle. Notice this is 1 pi. It's 1/3 of a pi more than that. So my reference angle is pi over 3. So pi over 3. You might notice all of these, the shortcut is whatever the denominator is stays, and it's always pi over that number. So I can look at this and go, my reference angle will be pi over 3 because that's my denominator. It's kind of helpful. So we have a mixed number. I want to write it as a mixed number, I should say. So 3 goes into 11 3 times. So 3 times 3 is 9 with 2 left over. So it's 3 2/3 pi. Draw our picture. We have half a pi 1, 1 1/2, 2. Notice that's not enough. So we have to keep going. So that's going to be 2 1/2, 3, 3 1/2, 4. Notice 3 2/3. That's more than 3 1/2, but less than 4 pi. So it's going to be over here. Draw a line to the x-axis. If this was 1, 2, 3, and then 2/3 pi, that leaves us with a 1/3 pi left over to complete the full 180 rotation here. So my reference angle is pi over 3. Again, you don't need any of these outside numbers. They just help you know where to draw in your picture. For F, again, I already know it's going to be pi over 3 because that's my denominator. I'm going to go ahead, convert this to a mixed number. So 3 goes into 14 4 times because 4 times 3 is 12, and that leaves 2 left over. So it's 4 2/3 pi. So we draw our T. We have half a pi 1, 1 1/2, 2, 2 1/2, 3, 3 1/2, 4. Notice we still have to keep going. So this would be 4 1/2, and this would be 5. Notice it's between 4.5 and 5 pi. So our line's going to be here. Connected to the x-axis, creating a right angle. If this was going around 4 times and then 2/3 more, that means this part has to be 1/3. So pi over 3 is my reference angle. Part G, notice 3 does not go into 2. You can't write this as a mixed number, but now we're going in the negative direction. So when we draw this, it's going to go clockwise. So if this is 0, this is now your half of a pi, 1, 1.5, and 2. So 2/3 of a pi, that's more than half a pi, but less than a full pi. So it's going to be over here. So we would connect a line up to the x-axis, creating a right angle. If this is 2/3 of pi, the angle in the triangle needs to be 1/3 of a pi to complete the full pi. So my reference angle is pi over 3. Okay, part H. We need to convert this to a mixed number because 6 does go into 11. Notice my denominator is 6 this time, so my reference angle should be pi over 6. That's a hint for you. So we have negative 11 divided by 6. 6 goes into 11 only one time with 5 more left over. So this is equal to negative 1 and 5/6 pi. So we're going to draw our t and we're going to go clockwise. So we have half a pi 1, 1.5, 2. 1 and 5/6 pi is almost 2 pi. It's more than 1.5 but less than 2, so it's going to be here. Draw a line to the x-axis. Notice if this is 1 and 5/6 pi, it's less from the full circle by 1/6 of a pi. So that's why my reference angle is pi over 6.